So we're here at Cambrios. Hi.
Hey Sharbax, good to see you again. Hello everyone.
So you're enabling the flexible electronics, right?
Absolutely Sharbax. What you saw here in this testing, this is a video of our film being tested. It is being folded, and we can fold our film at a 1 millimeter bend radius, which is very, very tight. And we can do this 400,000 times without a change in the performance of our material. So what you see data here is it's a less than 10% change in resistance of a 50 micrometer line, even after bending it 400,000 times. So why is this important? Tomorrow, if you have a phone that will open up into a tablet, imagine that, right? You start with the phone, you unfold it, and it becomes a tablet. And you're going to look at your phone maybe 100 times in a day, and over a year you're going to use it many hundred thousands of times. So it's important that the materials that are used to make those displays and the touch sensors on those displays are flexible and bendable. And that's where our technology comes in. What we make.
That's something that the existing technology cannot do, right?
That is something the current technology, which is based on indium tin oxide, cannot do. And what we make are these nanowires of silver, which are single crystal silver nanowires, very, very thin but very, very long wires of silver that allow us to make these transparent circuits that can sense where your fingers are in
You
touch.
say this is like spaghetti, right?
It is like spaghetti, but well-cooked spaghetti, right? When you start out with a packet of spaghetti, it's like stiff, but when you cook it, once it's not al dente, but when it's nicely cooked, it's very, very soft. And when the wires go on top of each other, they go like hug each other, and they go very nicely on top of each other, and nothing sticks out. So you can get these very thin nanowires that give you very high flexibility and highly conductive and transparent networks.
So it's conductive, transparent, it's flexible.
And it's also usable at very low temperatures, which allows us to coat these materials on plastic films. And this is a film which, if you heat it to 150 degrees C, would start melting. But our material can be heated to, uses very low temperatures, and we can coat and make transparent electrodes on these films without impacting the film performance.
So is this only for displays, or is it for, what is it for?
So right now, the first applications of this film are to make touch sensors. So this is a touch sensor made using our film. This uses 2 layers of our film, and think of it as 2 layers of transparent lines going along the long direction and along the short direction of your display, and when you touch it, it knows where your fingers are. So for example, on this HP Beats display, we have a touchscreen using our materials, so it tells where the finger is. You can draw things on it, you can write on it, you can pinch, zoom, do all kinds of things.
This is real product on the market. So
These are real products.
You and many.
We have many real products on the market. Lenovo uses our material for many, many products. So an example here is a 27-inch Lenovo all-in-one PC that uses our material for the touchscreen. There's a smaller Lenovo, 19-inch. There's also a 23-inch Lenovo. And very proud to say that now the Japanese company Toshiba has started using our material in their touchscreens. That's the first laptop.
So that, what does that mean? A big laptop, big touchscreen, great touch? What does it mean?
Yes, so our material can go to very low resistances. So when using a phone, you want a very high response time, right? So everybody has gotten used to the iPhone and the Samsung Galaxy phones to have very, very fast response time. When you want to make a large size touchscreen, to get the same response time, you need what is called a low RC time constant. So a low resistance helps to get very low response time, and that's what our technology can do. Low resistance on a film.
Which the existing technology cannot?
Which the existing technology cannot. So we can go 3 to 10 times lower in resistance than the existing technology, which means 3 to 10 times faster response time with our material.
So your target market is large displays? flexible, and also all the smartphones and small display? Where does it go?
Right, so in the large displays, we win market share because of the high conductivity of our material.
Did you talk about
and
market
we have
share
about 10 to 15% market share this year. We expect that to double next year. Now, going forward, we expect in the curved and flexible cell phones and tablet markets, we will have a very big share there as well, because the current technology of ITO cannot be bent or flexed. So we expect that with the coming changes in the display technology, where you have curved displays or bent displays or flexible displays, we will be able to get a big market share.
Do you have a flexible display smartphones to show?
Not right now.
Not yet.
What we have is this touch screen, which can be bent, and you can see on the screen that where we touch, a line is being drawn. So this is like, think of it as a wearable device or a flexible device. You could have something on your arm where you're touching and doing things. So this is just a demonstration of something like that.
So the future smartphone could look like this?
A future smartphone could look bent or curved like this. It could be something that goes around your arm. Right? It's not like a thick thing which you're sticking and then you're running. It could be something that's comfortable and goes around like a band. Could be integrated into clothing and things like that. And
what's the main challenge to get this? Because everybody wants this, right? So how much more time do we need? When can we get this phone? Can we get it in 2016 or a little bit later, or when?
So I think several of the big companies are talking about this. Of course, Samsung and LG have been talking about this for a while. There are many components in a smartphone. It's a very, very complicated device. So all those components have to become flexible, and that's what these companies are working on. What we are doing is enabling the touchscreen to be flexible and foldable, and we're making sure that that part of the device is flexible. And there are other companies like us who are working on other parts of the device, like the display part, the battery, and the integrated circuits, which have to be flexible and foldable as well.
Even the CPU, maybe.
Well,
but,
yes.
That'll take a while for high performance.
Right. So in the short term, what would happen is it'll be a foldable device, right? So think of it as a notebook, right, where you have something that you fold, right? So this part of the device would never fold. So you can put in, you can make a hybrid device with ICs that are not necessarily flexible and foldable, but then other components that need to be flexible and foldable.
Yeah, we just need the display to be flexible and unbreakable, and then the PCB and the battery can just be in a corner somewhere, and it's still awesome.
Absolutely. So it'll still allow us to make things that are very easy to carry and then can be unfolded into big, useful, very nice devices.
All right, so hopefully very, very soon we see lots of stuff happening with that, right?
We hope so. We are banking on that and helping enable that.
Right, what are you showing here?
Yeah, so in addition to all of these, we have a couple of completely different applications. So what you see flashing out here, these are light sources. These are organic LED light sources. So just like you have OLED displays, people are working on OLED lighting. And in order for the light to come out, one of the electrodes has to be transparent. So that's where, again, our technology comes into play, because in order to put a lot of current into these devices, you need the electrodes to have very high conductivity. And again, that is something that incumbent technology cannot do.
So it cannot work with ITO, this one?
This doesn't work with ITO. People use either metal grids, or they're looking at our material, where we can get to very low conductivity and get very nice uniform light emission.
All right.
And I'll show you one more cool thing. So imagine a day when the windows in your house and in your office are generating electricity. So this is a transparent solar cell, which could be part of your smart windows. So your buildings will be generating electricity by themselves. And so we are working with many companies that are making these transparent solar cells. These can go on the sunroofs of your car, in the buildings, on top of your phones when they are transparent. So a lot of applications for this.
Transparent. How transparent does it get?
So you can tune.
It's not as transparent as a touchscreen.
That's correct. So if you look at the window of your building today, what you want to do is keep the heat out and let enough light in so you can see. So we can tune the transparency of these windows to let maybe half of the light in and generate electricity with the other half. And then depending on the color that you want, you may want your corporate colors or colors that you may like in your house. So you can choose the color of the window and determine how transparent you want.
Is this rollable? So you can just pull it down, right?
This is all made roll to roll. So you could actually make a window shade out of it and roll that down, for
And that would
example.
totally be working.
That would
Roll
be
it down
working.
when you want, then you get 50% light, and you get
Absolutely.
power.
Absolutely.
You save electricity.
And if you want to look out and you want really 100% clear view, you can roll it up and you can see it like a real window.
So this is coming.
This is coming, and the precursor to that is this solar cell, which is flexible. You can see how thin it is. You know, it's unbreakable. Okay, and this becomes really interesting because let's say you go out hiking, right? You don't have access to electricity. You want to charge your cell phone. How do you do that? Well, there's a device for that uses this unbreakable unbreakable solar cell, and so it is integrated in here. So you hook it onto your backpack, charge this battery during the day, and you can use these connectors to charge your cell phones or your iPad at night or during the day. So here is something that is unbreakable because you don't want, in case you drop this, you don't want it to break. So
People can buy this?
People can buy this in the market. This is made by a company in Europe called Suntrica. This is called the Move Strap, and it's available in the market.
Awesome.
The solar cell is actually made by a company called Crystal Sol. This is a Vienna-based company, and it's a fully printed solar cell.
Fully printed.
Everything is printed in this using screen printing or a printing technique, and that is so cool. That is what is so cool about it. You can integrate this into canopies, into many other products, and again, you can fold these, roll these up, open them when you go camping. Maybe your tent will have the solar cell integrated in it, and you go unfurl your tent and you're generating electricity.
Can you cut any shape you want and put them on smartwatches or something else?
I think that's a little bit more difficult to cut on demand, but people are working on designs where you could do that, and you can just connect your wires at the appropriate places and use this. So yes, people are thinking about how to make that happen.
How's the efficiency of the solar panel?
So this solar panel is about 8% efficient. So this is like the amorphous silicon kind of efficiency. So it's not the highest efficiency, but it's the efficiency power generated per unit weight is very, very low. So the markets for this are going to be places where either weight is very important, your building is not able to bear the load, or you want something that you want to carry with you, where you don't want to take those thick solar cells made out of crystalline silicon.
All right, so we're going to see a lot of your ink everywhere in the world. Many companies are buying these and putting them in stuff.
We hope to sell a lot of these Sharbacks, but we hope that nobody is able to see them because it is transparent.